Good day. For today's presentation, we are going to be solving for lift and drag using the Gottingen 398 airfoil chart. To get the coefficient of drag, we're simply going to align the angle of attack we have on the bottom corner, on the bottom, and we're going to track all the way up to the coefficient of drag. And at 4 angle of attack, which is the one we're going to be using, we are going to be having 0.04. So we're going to write that down, 0.04. There you go. That is the coefficient of drag represented by CD. To get the drag, we're going to be using coefficient of drag multiply density over 2, multiply by the wing surface area, multiply by the velocity, squared. So we already have the coefficient of drag, which is 0.04. And the density we're going to be using is the one that is given at standard sea level, which is 0.002377 slug feet over 2. Then we're going to be using, for the area, 174 square foot and 130 feet per second squared for the velocity. With the given formula, we are going to be arriving with the answer of 139.80 newtons. That is for the drag, because it's the same thing to get for the coefficient of lift. For angle of attack, if you slide all the way up, we're supposed to get 0.7, but it doesn't really hit like the line, so we're gonna be rounding it off to the nearest number, so which is 0.7. So let's write that down. It's gonna be the same formula as the one we have. So we're just gonna have to replace the coefficient of drag to coefficient of lift. So since it's 0.7, we're gonna be using the same density at 0.002377 slug feet per second. Slug feet. Then we're gonna be using 2 multiplied by the wing surface area at 174 multiplied by the velocity squared. We are supposed to come out with 2446.43 Newton coefficient for the lift. That is for lift. It's technically the same formula, we're just gonna have to replace the coefficients. What if we have an angle of attack of 10? With the same formula, we're gonna be solving for drag. We're gonna be using the coefficient of drag, which is 0.08. Same density at 0.002377 over 2. Then we're going to be using the same area and the same velocity at 174 and 130. We are going to be arriving at 279.59 newtons of drag. We are going to be using the same formula for both, just different coefficient. For coefficient of lift, we're going to be using 1.1 times the density over 2, 174, 130 squared. We're going to be arriving with an answer of 3,844.39 newtons. If ever the line doesn't match or doesn't arrive in the same line, let's say at 14, it's not exactly 14 angle of attack, it's not exactly at 0.6 and it's not near 0.7. If it's near, we're gonna be using the number nearest to it. So for 14 angle of attack, we're gonna be using 0.6 for coefficient of lift. Wait, no. For coefficient of lift, we're gonna be using 1.4 and 0.12 for coefficient of drag. Sorry. The standard, we always use 0.002377 because that is the standard density for standard sea level at sea level. There are different airfoil charts, but for this one we use the Gottingen 398. There's also C80 airfoil, the M6 airfoil, the RAF15 airfoil. So there are multiple airfoils we can use, but for now we use the Gottingen 398 airfoil.